Hello everyone, welcome to Cloud Solutions Academy. I'm Naveen Balani. In this week's episode, we'll be talking about how can you migrate applications to AWS Cloud. So let's get started. So in this week's episode, we will look at how can you migrate workloads to AWS environment. So let's look at what kind of applications we're trying to migrate out here. Basically, we're trying to migrate a microservice application from any cloud vendor to AWS Cloud. The approach that I'm describing is for a microservice application, but the strategy can be used to migrate any kind of application to AWS environment. Now the application being migrated comprises of hundreds of services. It uses managed and non-managed databases for its persistence as well as reporting purpose. In terms of runtime, the application is deployed on virtual machines, and some of the application uses containers, basically a managed Kubernetes distribution for managing workloads. The application exposes all of the business functions as APIs, and it uses the API management solution provided by the cloud vendor to track and monitor API usages and performance like average latency, number of errors, and so on. With respect to logs, the application uses a common infrastructure to capture all the server and application logs in a central place and use the query capabilities provided by the cloud vendor to search for specific log events. The application also uses a lot of ad hoc jobs for task management and scheduling. For instance, launching an application once a file is received from a vendor. Central monitoring and alerts is one of the key features of the application, where all of the information can be viewed in a central dashboard with respect to API usage, server usage, monitoring, and setting up required alerts for notification. With respect to security, the application leverages the features provided by the cloud vendor, for instance, setting up firewalls, using tools to mitigate DDoS attack, as well as common web exploits. The application being migrated is a secure and compliant application, and it basically uses audit functionality provided by the cloud vendor to provide end-to-end visibility of the application as well as the environment. For instance, which user is accessing the environment, what data is being requested, and so on. With respect to resilience and scalability requirements, the application uses out-of-the-box features provided by the cloud vendor, such as auto-scaling and the use of a global load balancer. And finally, with respect to tooling, it integrates with the continuous integration and continuous deployment services provided by the cloud vendor to roll out applications effectively in various environments. Next, we look at how we can migrate this application to AWS environment. We start off with a migration strategy and a migration plan that allows us to migrate the application to AWS environment. The migration plan that I've described is fairly generic enough and can be used to migrate any application to AWS environment. So with respect to the migration plan, you first start off with organizing projects, buildings and roles, and set up the virtual private cloud for segregating your application environment. Once the basic infrastructure is set up, you then go about migrating managed and non-managed services to the AWS environment from the other cloud vendor. And this migration consists of application as well as database migration. Now, as the application uses virtual machines, API gateways, and ad hoc jobs, we basically look at how we can migrate all of these components into equivalent AWS services. Once the application is being migrated, next we look at how we can harden the production setup. For instance, which AWS services we can leverage to provide security and auditing. Once the production application is up and running, we look at how you can set up central log management to log various events and set up monitoring alerts based on required metrics and thresholds. And finally, with respect to tooling, we look at what compatible AWS services we can use for continuous integration and continuous deployment processes. to roll out applications effectively in the required environments. Now let's start with the first step, organizing projects, buildings and rules. And I've divided each of the activity into two parts, plan and execute, and some of the best practices that needs to be followed for that given activity. So the first step in the AWS migration is to basically define an AWS organization to centrally govern your environment. And basically you would create a root organization and then create various sub-organizations to manage different kind of projects. For instance, you could create sub-organizations based on environments like development, pre-prod and production, or based on client specific projects. And as a best practice, you shouldn't allocate any resources to the root account. What I mean by resources is that you should not start any AWS services that will incur any bill to the root account. The root organization should be only used for managing and securing sub-organizations, allocating the required policies to it, and also used for centralized billing across all sub-organizations. Also, with respect to identity and access management, set up the required roles and allocate users to the roles to provide access to the required AWS services. And as a best practice, grant only the least privilege to carry out the required activity. With the AWS organization created, next you set up virtual private cloud to isolate your AWS resources. Now while creating the VPC, you would first select the AWS region and set up CIDR ranges for your subnets. Now if you need to route traffic between VPCs privately, you basically need to ensure the CIDR ranges between these VPCs doesn't overlap. So as a best practice, it's a good idea to keep track of the CIDR ranges across VPCs and make sure they don't overlap, because in future you may have a requirement to route traffic between VPCs. Also as a best practice, keep all the AWS resources in the private subnet and front end it through a public load balancer or an API gateway based on your requirements. Now for resilience and scalability, plan to have 2 or more availability zones configured based on your application requirements, and you can also set up network access control list to control traffic at the subnet level. Now with the basic infrastructure migrated, we look at how you can migrate managed and non-managed services from other cloud vendor to AWS environment. Migrating a database needs careful investigation based on your existing database infrastructure. Broadly, the migration consists of two parts. One is environment setup and second being data migration. For environment setup, you basically explore what AWS managed service you can use. For instance, if your application is using MySQL, you have a choice of using AWS RDS managed MySQL service or maybe Aurora DB, which is compatible with MySQL. For non-managed or any database service which cannot be migrated, you basically need to set up the appropriate environment in AWS and basically rewrite or look at alternatives to migrate the application which uses the database. For instance, let's take a simple example of migrating a MongoDB to AWS Document DB. And if you have queries like db.object1.insert, the dot operator doesn't work in Amazon Document DB, and you need to replace dot with dollar prefix to make the queries work. So basically you need to be aware of what capabilities are provided by AWS and what are the limitations of migrating databases from other cloud vendor to AWS. For data migration, this depends on the size of your database and if you can afford any downtime. For instance, if your database size is small enough, you could use export and import database tools provided by the database vendor or the cloud vendor. For large database migration, you can use tools like AWS Data Migration Service to migrate the data while your existing database systems are still functional. Once the data is migrated, you can point the application to use the new AWS database instance. Also, while setting up the managed RDS database, do change the default DB parameter group parameters based on your application requirements. For instance, logging query which takes greater than 2 seconds. The parameter changes requires a restart. So do plan well in advance to log all the required parameters for any performance and audit requirements. Once the database is up and running, set up the required monitoring alerts like number of active database connections, high CPU usage, and so on to track your application database usage. Also do check out any existing CloudFormation template that can help you to set up the non-managed environment, like the MongoDB cluster CloudFormation template, which you can use to set up the production topology on AWS instance. Next, we migrate the applications to VM, including standalone and managed instances. Now, if the application leverages Docker containers for deployment on virtual machines, migration path is pretty straightforward. Publishing containers to AWS Container Registry and accessing it via the AWS virtual machines. Alternatively, if your application does not use a container solution, depending on the application, you might need to refactor or rewrite the code based on the dependencies used by your application. For instance, take an example if you're using a Google App Engine and it has a lot of SDKs dependencies for interacting with Google services, and you're trying to port that application to AWS Cloud. First, you need to strategize how to migrate the application. There are multiple options out here. You can remove the SDK dependency and port the application to container and deploy it in AWS. Or use an equivalent service like AWS Beanstalk, where you take care of only refactoring the application and leave the infrastructure and other aspects to Beanstalk, similar to App Engine. Secondly, if your solution uses EC2 instances, you need to create an AMI that contains all your application code and use that image for auto-scaling. As a best practice, expose your application endpoints for periodic health check by the AWS load balancer. The endpoint would be typically the home page or maybe a simple API request that sends a successful response on execution. And finally, monitoring of the resource is a key aspect. So do capture the required metrics and set up alerts like CPU usage, number of active instances, and so on based on your monitoring requirements. Now, as the application uses APIs to expose the application functionality and uses an API gateway from other cloud vendor, this needs to be ported to an equivalent AWS service, primarily API gateway. API gateway supports OpenAPI specification, and if your application uses OpenAPI specification for service metadata, it can be easily imported into AWS gateway, and you can create routes and target it to the required application endpoint running in AWS through a load balancer. If your application does not use any OpenAPI specification, you would need to manually create the required routes and targets through the API Gateway Administration Console. One of the important aspects that you need to keep in mind while choosing the API Gateway is a choice between HTTP and REST-based APIs. For instance, if you need detailed API logs like tracking the complete request and response, monitoring, or native integration with AWS Cache Service, you need to go with REST APIs. If you need a simpler, cost-effective way to manage APIs and provide integration with AWS services, you can go with HTTP APIs. Once the API request response is being logged, you can set up monitoring alerts to track metrics like average API latency or 500 errors and notify the required team for further action. Now, as the application uses a lot of ad hoc jobs for scheduling and task management, based on the application programming language and its dependencies, we can evaluate various services like Lambda, or maybe serverless containers solution like Fargate, or even EC2 instances which runs the ad hoc jobs. And if you decide to use Lambda, you basically need to package all the dependencies into deployment artifacts, and that would also end up changing your continuous deployment processes to build and deploy the Lambda service. Once your Lambda application is up and running, you can trigger it automatically from the supported AWS service, like triggering the Lambda function once the file is uploaded into an S3 directory. Now, as a best practice, if you're using Lambda, is to package all the dependencies, including the Lambda SDK, so your code doesn't break in case of a major SDK update in future. Even though Lambda is serverless and it decreases your cloud cost substantially, ensure you know how costs are calculated based on the runtime usage. For instance, if you're using recursions, that might increase the cloud cost significantly. Also be aware of the cold start problem with serverless options. For instance, let's assume you have created a Lambda function to reset the user password, and that is not used frequently. Now, once the user resets the password, it might take time by the AWS runtime to launch the Lambda function, and the reset password function would not provide the expected latency to the end user in the given time frame. So do keep track of such activities, and you can overcome this by keeping your service alive or hot based on frequent intervals. Now, once your application is deployed, next step is to harden the production setup. AWS provides a host of services to secure your infrastructure, as well as provide services and tools to audit your environment to make sure it is aligned as per the defined security guidelines. For instance, you could use CloudTrail to log and continuously monitor AWS account activities across your AWS environment. For instance, what changes was made to the AWS VPC configuration, which user account made the change, and what all management APIs were executed. Similarly, to get insights for unauthorized access or even a SSH brute force attack, you can enable AWS Guard duty in your AWS environment. For SSL certificates, you could use AWS Certificate Manager. It provides free SSL certificates that can be used with the AWS load balancer. In terms of securing your application, you can set up WAF, Web Application Firewall, and configure common web exploits rules to log and block traffic. There are a lot of pre-configured rules available from the AWS ecosystem which you can leverage to get started. And some of the best practices for managing the production environment includes capturing enough metrics and track usages like CPU, API latency, database connections, and alerting the required team in case the thresholds are not being met. So as a best practice, do spend enough time on defining the monitoring requirements and what needs to be captured. In terms of production setup, run the production resources in its own sub-organization and VPC and manage it through the root account. I talked about how to design AWS organization earlier and how to create root and sub-organizations based on environments. In terms of continuous monitoring, review users and roles, firewall and security configurations allocated to the production environment from time to time, and check the insights from required services like AWS Guard duty, check for unauthorized access, and block the required IP address. In terms of connectivity, it is recommended to keep all the AWS resources in a private subnet and use a bastion host to connect to your internal and private AWS infrastructure. Now, with the production app up and running, next steps are to ensure you have enough visibility on the production environment. For instance, ensuring all logs are being captured and you can search for required events, errors. If you need to capture all logs centrally to AWS CloudWatch, make sure you capture the logs and send the logs from virtual machines or services which don't log by default to AWS CloudWatch. In that case, you need to install CloudWatch agent on the VMs to capture and send logs to AWS CloudWatch service. In terms of tooling, if you're already using tools like Jenkins to build and deploy applications, you may continue to use it and modify the pipeline to use AWS CLI for deployment to the required AWS environment. And if you are building your continuous deployment processes from scratch, you could use tools like AWS Code Pipeline to manage your continuous deployment processes. And in terms of best practices, make sure you are capturing enough metrics for your application as well as the environment to ensure automated, continuous 24/7 monitoring and trigger notifications to the required teams once the threshold values are violated. Also track the logs that is being accumulated by the application and the environment and the size of the logs, and if the logs are being transferred to CloudWatch across VPCs, as the CloudWatch logs might grow substantially over a period of time and can incur significant cost. So as a best practice, you can keep only the frequent logs in the console and transfer all the logs to a less frequently used S3 storage and maybe later to Glacier storage for archival and audit purpose. So with this step, we have successfully migrated the microservice application from other cloud vendor to AWS environment. This concludes our session. Hope you found the migration guide useful. And basically this migration guide can be used to migrate any workloads to AWS Cloud. Please do subscribe to the channel to receive regular updates. Till then, happy learning and thank you for watching.